Okay. Assalamualaikum. Bismillahirrahmanirrahim. Today I want to share about my new developed apps, which is basically this to convert from the absorbance, transmittance, and reflectance data from UV-Vis and IR measurement to the optical band gap using Tauc plot and also Kubil-Kamang for reflectance using these simple apps. So it doesn't have to go to Excel and then you need to compute one by one times by A and etc. convert to EV. No, so it's just using these simple apps. So it's very user friendly and also you just give your data and it can compute all with exact measurement and exact regression with the R square. Okay, so basically, you need to prepare the data input, your UVs and an NIR like this. So this is example my data input, my sample UVs measurement. So example, this is the UVs absorbance test. So first column must be wavelength. Second column is the intensity for absorbance. Similar like this reflectance. So first column is your wavelength and second column is your um, reflectance intensity. So just simple and make sure it doesn't have any other character instead of to the data. So it's all mass numerical data. So you cannot put your sample name like L1, L2, no. So it must all contain the numerical data. So we just put in. So you can see here this is the title and then it is initiated by me myself and then you have the key relation equation that used to convert from the UVs and R data to the band gap. First, you must to go to the sidebar here. We have the measurement setting, which is absorbance or transmittance or reflectance. So it is up to you. So we can take the case of absorbance example, and then this is your sample thickness. Maybe I take this as 1 millimeter. So you just upload the data here. So browse files, and then we go to the files that we used before. So it is the absorbance, and then we put in. Okay, I prefer the input data must be in CSV. Okay, because if you use TXT, it doesn't have a column uh, restriction. So for CSV, much better. So you put the data, and then it have the data preview. You can check between what in apps and also in what in your CSV, and then select column. So we have the wavelength column and the absorbance column. So I take wavelength is starting 200 nanometer and then absorbance is the second column. So you can have the calculated quantities here. This is EV energy in electron volt, and then this is the alpha. Alpha here is means the absorption coefficient, and then the tau for direct and indirect. You can check on your own, but I want to go to this one. So you have your raw spectrum. You can check whether it is similar to what you have in your measurement. And then you have the tau direct and the tau indirect, which is the tau direct is the absorption coefficient versus energy square here. And then tau indirect is absorption coefficient is P half square root versus HP. Okay, now this is what we compute or we just convert to the absorption coefficient. Now, how can we get the band gap? So you just choose the energy window here. So example, this is the tau plot of direct. This one is tau plot for indirect. So we just select this. Okay, you can see my cursor is moving. So you just choose the energy that you want to do the linear regression energy window. So maybe you can put like this. Okay, and then you can select here R square. This is the measurement. Sorry, not the measurement. It is the quantity that makes sure that you are taking the correct linear regression and the correct energy window. So if it is below than 0.95, so it is a poor in linearity. So you must select any other energy window, and then you can see the graph also is updating. So you can see here the R square is 0.97, so it is very exact, and then we make sure it is near to 1. Okay, yeah, it is not okay. We try to make it more exact. Okay, so maybe this one is the correct one with. Okay, this is 0.991, the R square. So maybe it is the correct linear regression. And then we have the estimated direct band gap is 3.328. Similar to this one, you can just use your cursor here and then you find the R square. Make sure the R square is higher than 0.95. So if it's near to 1, so it will be the most correct one. So maybe this is 0.992. So you can take 2.883 for indirect and then 3.228 for direct band gap. And then you have the visualization also. Okay, this one also you can save the image. Okay, if you want to save, you can have the image like this. Okay, so you can have the image also to put in your um, paper or on your thesis. Also, we have the visualization in EK wave vector space. So this is for direct, this is for indirect. Also, it is the value of EG is um, aligned with what we compute here. We try to do the regression. So you can also save the image. Okay. Okay, you can find image here. Okay. So and also it have the suggested methodology or something to write in your thesis or your what's it called paper, and then it have the process data if you want to download, and then you can get the wavelength, HV, alpha, alpha, tau direct, and tau indirect. So hope you can enjoy these apps and make it easier for you to compute the band gap. That's all. Thank you.